Hi, my name's Tim Skornia. I'm the mount maker here at the St. Louis Art Museum. I've been a mount maker for 7 years and an artist, welder, and fabricator for 15. Today I'm going to be discussing with you a Judd box project I completed in late 2019. So here we have an image of the existing mount that was used to move the object around the building. This was an old idea, a turnbuckle resistance fit mount. The problem with this was the fact that you need to step inside of the box for installation, putting pressure on the structural joints. As you can see here, adhesive was used on the sculpture to join the aluminum. These are the two aluminum plates in acrylic inlay. The problem was any resistance against this joint would most likely rupture the seam. This illustration depicts what was the preliminary ideas. The idea was to stop the object or Judd boxes from rocking side to side while being shipped across the country. So after researching, talking with conservation and installation, and looking at every clamp bracket fixture system I could find, I came back again and again to just a simple right angle framing clamp. Here I'm starting to work out some of the details for how this bracket would be assembled. As you know, as a mount maker, you most likely are not going to be able to find what you're looking for without having to fabricate it yourself. So having the ability to use Autodesk or any system like that is very beneficial. So here we have the bushing block. We have the control block. And we have the threaded rod. This is a drawing of what is the bottom plate of aluminum. Here we have the bottom plate with the locking plate attached with fasteners, as well as the two plates that would be welded in position on top of the bottom plate. Here we have the internal locking plate and what is the pitch angles for weld placement. This image, we start to see what's going to happen internally. So you have this hole here, which is milled out, and this is to accommodate what will be the spring pin to allow clearance for the spring pin to set into. Here's where your threaded rod will come through. This is where your bushing block will be press fit into. And this is what it looks externally. This is what it looks like. This is the threaded rod control block. So this is the bottom block. Here's where your threaded rod will pass through. This spacer here, this is threaded. So this is to allow for the threaded rod to turn within the block itself. And then here's your secondary bushing, and that is to stop it from swaying side to side within the block itself. And again, here's what it looks like externally. Here's your bushing, press fit into the top. The threaded rod, to me, it's even important to show the most minute details down to the spring pin, what size, the hole diameter. This just makes it easier for the machine shop or fabricator, whoever that is, to put this thing together for you if you're doing it out of house. So I think it's very important to break it down piece by piece, component by component, just to allow for you to not have to rework anything in the future. Here we have all those drawings and all the components and how they work together. So you have your bottom locking plate, your top, you have the control block, the bushing block, and the threaded rod, and how they all work together to make a simple right angle clamp, just on a larger scale. This is what they look like when they came back from the shop. Overall, very good job. The external welds were decent. They sat at about 1/16 above the aluminum. Nothing came in contact with the piece itself, so there were no pressure points. There was no welds internally. All the internal welds were fusion welds, or if they were welded, they were sanded smooth, which was all specced out on the drawings. And the internal plate here, this is where the LDPE will be attached, and the external plate is where the poly suede will be attached. So to your left, you'll see the LDPE, low density polyethylene, the 32 mounting brackets all on a pallet as they came back from the shop. To your right is an in-process photograph of everything that had to happen before lining the components. So here we have the LDPE after it had been cut and all the edges had been beveled. Here we have some more in-process photos. You have your poly suede, your double stick tape. Velara was used to line the bottom edge where the components came in contact with the Judd box itself. This is where I did all my assembly and beforehand would wipe everything down with denatured alcohol. The poly suede was adhered with hot glue to the external surface of the locking plates. Before every installation or shipment, I always will carry out a test fit. This is an image of myself doing a test fit with one of the other preparators that works at the St. Louis Art Museum. To your left is an image of an objects conservator applying Teflon to the LDPE to act as a secondary barrier. To your right is an illustration done by myself of the installation crew putting on all the fixtures to the Judd boxes. This was carried out because of image rights concerns, and luckily I went to art school so I can draw pictures. Here we have an illustration of the suction cups that were used, 4 to either side. That would be 4 art handlers for each Judd box as they place them on pallets. Here are all the fixtures in position on each Judd box as it was placed on its pallet. This image is showing the slots that were cut into the foam and Velara to accommodate the fixtures themselves within the crate. You can see how the Teflon was used to act as a barrier in between the fixtures and the Judd boxes themselves. This illustration is showing what the Judd boxes look like packed within the crate and how all the foam worked to accommodate the fixtures themselves in all the slots that were cut. Here are the skid mates our objects conservators, Raina Chow and Hugh Shockey, developed. They worked with their contacts to come up with these. I don't know much about them. They could give you all the insight you need. I'm sure they would be more than willing to talk to you. If you have any questions, just email me after this or at any time and I can put you in contact. Here we are loading into the truck. Everything was a success. Moving on to somewhere else in the country for exhibition. Here we are at the end of the presentation. Hopefully it was not too short, not too long. I would also like to thank the API department here at the St. Louis Art Museum, headed by Christopher Moreland. I am very proud to be a part of this department, and I think we do an excellent job overall. I would also like to say, keep making, keep mounting, be safe out there, people.
Thanks so much, Tim. That was wonderful. I'm wondering if you're ready to answer some questions.
Yes, absolutely.
Fantastic. I might start off and ask you one. Can you talk to us a little bit more about the design process? The way that you used Autodesk, was that correct?
And Autodesk 360 Fusion.
Can you talk to us about that?
Huh? Okay. Yeah. It's a software program, Autodesk 360 Fusion 360. I have a scaled down version. I don't have all the extra amenities that some of them have, but for doing 2D drawings, it's ideal. And it just makes it easier for me to break down all the different components to then send out to another machine shop if they're going to do that work. So.
Thank you. Fantastic. And how about a little bit more about your problem solving process? The design of it and what you were trying, like what was the problem you were trying to solve, and then how did you come to that solution?
Yeah, so so what was going on with these Judd boxes is the way that the panels are joined, there's most likely like a dowel system that's within them, like a dowel rod, dowel pin system that's press fit in, and they are most likely adhered with an adhesive. So we were having an issue with, we thought it might buckle while it was being transported across the country. And I came up, we talked through a lot of different solutions, like building an entire cage that surrounded the entire piece. But all those different ideas would require somebody to have to step inside of the piece or along the outside, and it could allow for damage. So doing a simple right angle clamp was the best solution I could come up with.
Fantastic. Thank you. That's wonderful. Can you talk to us a little bit about the, there's a question here and it's saying, was that milled on a metal lathe? I guess they're asking about the manufacturing process.
Yeah, so all that should have been, that was probably done on a Bridgeport. So yeah, it would be on a stand-up mill machine. I was a machinist in the past before I was a mount maker. So I knew a little bit about how to do technical drawings like that to make it pretty easy for them to transfer over into their file. So yeah, that was most likely done on a mill, not on a lathe.
Thank you. There's another question here that says, have the Judd Foundation or other institutions with similar pieces adopted this method?
I'm not sure. I don't think so. I mean, I was not in contact with the Judd Foundation. I didn't want to go through that process of contacting the Judd Foundation to find out if I could use these images. That's why I drew everything out. So I am not sure, but we own that particular piece. So that's why I was able to do what I did. But as far as image rights, I can't reuse those images and try and get any kind of, I can't, I can't use them myself.
Yep. Another question has just come through. It says, did you have to work closely with the Judd studio to develop the brackets?
No, I did not. I did not work closely with the Judd Foundation or the Judd studio at all. I worked closely with the other museum that the objects were going to, and we compromised with the solution that could get the Judd boxes there, because we were afraid of shipping them across. They were going to New York, so we wanted to make sure that they were safe all the way up to the Northeast from St. Louis.
And so did you do an evaluation of how well they worked? I guess before I ask somebody else's question, I just wanted to understand, was there an evaluation done of how good this method worked?
Yes. Yeah. So I evaluated. Yeah. I mean, I did a test fit and I went through and I checked the overall consistency of each component. I had to mess around with how it was threaded. There was some press fit, stainless steel press fit fittings that work to hold in the threaded rod so that it can't twist side to side. So yeah, I played with it quite a while to make sure that everything worked seamlessly.
And even after they were used, like it all just worked well after it was used and there was positive feedback?
Yes. So they made it to New York and it was successful. And I heard that everything went really smooth and they will be returning in the next 2 months. So they will be coming back. That's a fairly recent project.
Fantastic. So there's a question here about so the Teflon for vibration, was it used for dampening or was it used for contact issues?
Not for dampening, for contact issues. Are you talking about the Teflon?
Yeah.
Yeah. So the Teflon, yeah, that's for friction. So the dampening system, yeah, there's not really a dampening system within that. But yeah, that's more for friction against the acrylic. So it acted as a secondary barrier in between the LDPE.
Thank you. There's another question here that says, what kind of documentation did you send along with the object about the supports? Did a courier go with the shipment?
Yes, our objects conservators went with the piece itself. And yeah, it had full documentation, an entire breakdown of how to assemble, take them apart. If anything fails, I sent some special tools
to take things apart.
Thank you. Another question has come through. It said, did you choose to fabricate new clamps instead of retrofit a standard right angle to save space, or for another reason?
It was the scale. So I tried to get, the ratio wasn't correct. I needed to be able to span a certain amount of square footage of the piece to accommodate how heavy it is. Each one was around 400 pounds. So they needed to, a normal right angle clamp, I think on average is about 3 to 4 inches in length. These are 10 to 12 inches in length. So
wow.
It's double the size.
Yep. Another question is around sort of lifting. So did you have to lift the cubes to place the braces on the corners on the floor side of the cubes?
Yes.
Did you have eight preps hold it while those braces were placed?
No, we used ethafoam. We used padding to put underneath them. And then that's how we got the bottom braces on. Sorry if I didn't show that in the slide, but yeah.
In a follow-up to that, someone's asking, could there be an alternative way to move these without needing 8 art handlers? The pallets are difficult to slide away with that many people.
Yeah, I mean, you could build a secondary skid, and you could shim the sides potentially, but again, I wouldn't try to shim this because of how it's assembled. It's all adhered together. So if you tried to rig it in a way where you would put shims underneath to get straps underneath it, I think you could jeopardize those joints. So I would imagine, yeah, you need 4 art handlers, not 8. So it's 2 to a side, so 4 each to place it.
Yep, thank you. And there's another question about how did you judge how tight to clamp the boxes without stressing them?
That's a good question. So yeah, I played with that quite a bit with the LDPE and its density. So yeah, I mean, how that right angle clamp opens up, it opens its max capacity is just to fit over the threshold of the piece. It's just to fit. It's a very snug fit. And then you just have to tighten it maybe 2 turns to get it to lock. I didn't want to make it over big, so then I would have all this excess threaded rod sticking out. So yeah, I played with that quite a bit also. So I just took into account the thickness of the aluminum, the acrylic, as well as my LDPE and my aluminum plate itself, added all that together and added in about 1/16 of play. So they're very snug fit. You can't really use them for framing. They're specifically designed for just those boxes.
Okay, great. Thank you. And then there's some questions here that are related about how much time did the whole project take? And, so how long did it take to develop the solution, and just sort of how much time did they take to machine? So lots of time questions.
Yep. So around 6 months, we started talking about how to develop an idea. We had a couple meetings, and then I did a couple preliminary drawings for approvals. Everything I do at the museum goes through an approval process anyways, and that all is stored in TMS so anybody can see it. But yeah, so the approval process, once that's agreed upon, then again, we had to have where the objects were being sent to. They agreed upon paying for some of this stuff, and then after that, I put together the drawings, and then those were sent out. And then once they hit the machine shop, it doesn't take long to do those CAD drawings, maybe a week. And then once they approved everything from their end, and they take those drawings and it's in a PDF format, so they can readjust anything that they need to for their particular CAD program or other system that they use. And so all in all, about 6 months.
Wow. Thanks so much, Tim. That's all the questions for now. So thank you. Mm-hmm. Back to you, Mac.